To make accurate predictions using an AI model, it is essential to optimize the model's performance. Therefore, in this video, we will explore gradient descent, which is one of the most important methods for optimizing an AI model. Here we have 4 data points, and we want to find the optimal prediction line based on these points. Among the green line and the red line, which one would be the better choice? You would naturally think it's the green line. So why do we choose the green line? The reason is that the difference between the actual values, represented by the blue points, and the predicted values, represented by the green line, that is, the error is very small. A small error means that the predicted values are close to the actual values. Therefore, an easy way to find the optimal model is to look for the line with the smallest error. As shown in this slide, finding the optimal prediction model means determining the slope and y-intercept of the prediction model, hx, that minimizes the errors, which are the differences between the predicted values and the actual values for all 4 data points. However, since these differences can be either negative or positive, methods that minimizes the sum of the squared differences are typically used. Visually, minimizing the sum of the squared differences between the actual and predicted values can be represented as minimizing the sum of the areas of these squares. Minimizing this sum of areas is a method to find a good prediction model. This approach is the core principle of the least squares method, which is widely used in regression analysis. Through the least squares method, the slope and y-intercept of the model, hx, are obtained using such mathematical calculations. Let's look at how to derive a model using the least squares method with a simple example. When trying to find a linear model to predict house prices based on house size, the easiest method is to use Excel. You can plot house size on the x-axis and house price on the y-axis to create a graph, and then add a trend line. Excel's trend line feature makes it easy to obtain a linear regression model, and this process is based on the principle of least squares. In other words, by calculating the slope and y-intercept using the mathematical formulas of the least squares method, you obtain a model that predicts house prices based on house size. So, can we use mathematical formulas like the least squares method to obtain the optimal model in artificial intelligence? To answer directly, using methods like the least squares method can be challenging in AI, so alternative approaches are needed. We categorize models into linear and nonlinear based on whether the y values have a linear relationship with the x values. Linear models include not only simple linear regression, as shown in the previous slide, but also multiple linear regression and polynomial regression. On the other hand, nonlinear models do not combine x variables linearly and use nonlinear functions such as exponential functions and logarithmic functions. While the least squares method provides a direct solution for linear regression models, it is difficult to apply to nonlinear regression problems or to deep learning models that will be explained later. Therefore, in artificial intelligence, we use an iterative optimization process called gradient descent to find the optimal model. Before explaining gradient descent, let's first understand the concepts of cost function and loss function. The loss function measures the error for a single training data point, which is the difference between the actual value and the predicted value. In contrast, the cost function represents the average error across all training data points. Common cost functions include mean squared error, which squares the error values, and root mean squared error. In artificial intelligence, the optimal model is found through an iterative process of minimizing the cost function, known as training. As explained in the previous slide, finding the optimal prediction model involves minimizing the cost function, which represents the difference between the actual values and the predicted values. Let's illustrate this using a simple quadratic cost function by assuming the value of n is 1. The cost function will have a downward-facing parabolic graph, similar to the graph where y is a function of x squared. To find the minimum point of the cost function, we need to determine where the slope of the tangent to this curve is 0. To find the slope of the tangent, we differentiate the cost function to compute this slope. To summarize the method for finding the optimal model in artificial intelligence, it involves determining the model that minimizes the cost function, which represents the difference between the actual values and the predicted values. Starting from an arbitrary point on the cost function graph, the goal is to find the minimum point. Assuming the prediction model is wx plus b, with two variables w and b, we compute the gradient values by partially differentiating the cost function with respect to each variable. We then find the values of the variables at the point where the gradient is 0. The method of finding the optimal parameters using these differentiated gradients is called gradient descent.